No, the problem solving sessions, they are not, it won't be held tomorrow. Yeah, just these revision sessions, because we have already done with the problem solving for all the weeks. Now only revision sessions are left. So today is the revision session for week 5 to 8. From tomorrow it will be 9 to 12, and on Friday it will be previous previous quiz solving. So let's wait for a few more participants, then we'll start the session.
Sure, sir. So in the meantime, my brothers join. Is there any place where we can access previous years or previous sense question paper for stats one?
Okay, there are a lot of sources from where you can get those papers. Officially, they don't provide those, but unofficially, you can find a lot of sources out there which provide those. I don't have those websites with me, the name of those websites, but if someone has those, they can post it in the chat box.
Officially, it's not provided, you said, right?
No. Officially, it won't be provided. Officially, what if we will be solving the previous end term on Friday, so that will be only that will be officially available.
All right. Thank you.
So good evening, everyone. Mostly we'll start from again the basic week 5 only, that is permutation and combination, I think, which is all of your favorite topic. So
hello, sir.
Yeah.
Sir, I have a doubt regarding the mail of additional content.
Mhm.
They are saying that geometric distribution will come, but
Yeah, don't worry. Basically, there will be questions from geometric distribution, and the material will get uploaded by most probably tonight. In the additional content, you can see it. I think now you can see only normal distribution, right? In the additional content.
Yes, sir.
So by max to max tomorrow, you will that it will be added up. It will just be 3-4 formulas, and it's a very straightforward distribution. Even if we'll
will we have to go through a normal distribution as well?
No, only geometric. Okay.
Sure.
And even if it's needed tomorrow in the revision session of 9 to 12, we'll try to get in some questions from geometric also, so that it becomes easier for you.
Thank you, sir.
Sir, I have a few questions. Could I ask them after class, or
questions related
to these weeks? Some questions I found.
Okay, we'll try to take that if we have some time left after this revision session, or else what you can do, if they are related to PYQ, then you can wait for I think today Thursday. I think your PYQ session would be Thursday or Friday. For that day, you can wait, or you can post it in Discord. So we'll take up all the solve the questions, whatever you have.
Okay, sir. Okay, sir.
Anyone, anything else? Okay, so basically, I think we have done this in the last quiz, before the last quiz also. So basically, in the starting from week 5, what do we get? The whole idea or the skill we try to achieve is that how differently we can calculate or count different possibilities. Okay, so in general, what happens is that can anybody tell me what are the two fundamental principles that we learn in week 5?
Addition and
Addition rule of counting and multiplication rule of counting.
Yes.
Addition rule and multiplication.
Correct. So the whole idea is to given a question, you need to find out that either there is a possibility, means we can interpret a question that either this event is happening or that event is happening. In those cases, we'll be using the addition principle. And if it's kind of a question where there is a means both the events are occurring simultaneously, and you are trying to find out a possibility combining both the events, those kind of cases like this is occurring and that is occurring. So that and is a crucial thing which leads us to apply the multiplication principle. So if you have to take up a question just regarding this, it can be like, let's say you have been given that to travel from A to B, there are, let's say you can take train. There are, let's say, 2 types of train. There are 3 types of buses, and there are let's say this is if say bus, then let's say it is again 2 types of car. So what are the possible ways you can travel from A to B? It would be anyone?
3 ways.
7.
7 ways. Because either you can take any of the 2 trains, or you can take any of the 3 buses, or you can take any of the 2 cars. So there are total possible ways is 7 possible ways. Now, if I have to add on into this, let's say from B to C again, you can travel. Let's say there are 4 types of buses and 2 types of flights. Now, what are the all possible ways you can travel from A to C?
14 into 7.
42.
So the first one is 7 possible ways. For this part, we'll be using this part, it would be 7 possible ways, and for this part it will be 6 possible ways, right? And now when we are considering, it can be like out of the 2 trains, I can just picking up any one of the trains, let's say, and let's say T1, and it can be let's say B1. There can be T2 and let's say B1. So this way, for each possibility of the 7 possibilities, we'll be having 6 possibilities, right? So it becomes 7 into 6, that becomes out to be 42. So this is how basically the addition and multiplication principle we can apply to. Now, if you have to see, it can be like there can be arrangement of question, means arrangement of letters or whatever. In that also it is same way. Like let's say there are 4 letter words you have to find out, and you have to make it out of 26 possible letters. So what are the possible ways you can do it? Anyone? So this can be filled up in 26 ways, this 25 ways, 24 and 23, right? If you are doing repetition is not allowed.
Yes, sir.
So when you are doing this, it is also you have to keep in mind that either repetition is allowed or not. You have to take care of all those things. Okay.
Yes, sir.
So okay. So one question which I'd like to take up in let's say that if you are, let's say, given 4 flags. Okay. Just give me a second. I'll clear it up. Let's try to, I'll just give you 2 minutes. I'll just brief out the question and let's see if we can solve it. So let's say there are 4 flags of different colors. Okay. Of different colors. And how many different signals can be generated? Different signals that can be generated. If one signal, that is, if you have to produce any signal, it requires use of 2 flags, one below the other. Okay. So how many different signals can you produce? So there are 4 flags of different colors. First thing is there are 4 flags of different colors, and I'm asking you to produce different kinds of signals and to produce any signal, you will need two different colors of flags.
12.
One below the
12.
other.
12.
All are you getting the same answer?
Sir, that would be 24, sir.
Why do you think 24?
Because we can inverse the order, right?
Okay, inverse the order. Okay, you are saying it should be 24. Anybody who want to defend it, like why it should be 12?
Yes, sir. So when we do 4 into 3, that is for the first flag we choose, there's 4 options, and the second flag there's 3 options.
For
Even
a signal, we need 2 flags, right? This is flag 1, this is flag 2.
Sir, that would be 4C2 into 2 factorial, right?
That is 4P2, that is 12.
So may I?
Yeah.
So here we are arranging the flags. So order is important. Then 4P2 we can use permutation.
Okay, 4P2.
So
Anyone else?
solving
So we
that.
can say, sir, that since we have 4 flags and we can choose 2 flags out of them, that is 4C2. But the order will matter here since we are talking about signals. So we can multiply that with 2 factorial, that is same as 4P2
See,
equals to 12.
there are different ways to do it. If you're telling that for picking up one signal, I need 2 flags, right? So it can be done in 4C2 ways. Then again, as Chetan said, their order will matter. It will be 2 factorial. This can be one possible way to approach. Another possible way is that to make any 2 signals, I will need to, there are 2 positions. So in the first position, I can fill out of 4 flags, any of the flags. In the second position, I can fill any of the 3 flags. So this way also you can think about it. Okay. Is this clear? Okay.
Yes.
So now,
Sure.
yeah, anyone saying something?
Yeah. You gave a second approach, right? The first flag can be filled in 4 ways and the second flag can be done in 3 ways. Then the answer becomes only 12. We don't get that 24.
Yeah, that is 12. That is 12. The answer is 12.
But ideally, we should get 24.
No, the answer would be 12.
That is wrong. That is my
2
calculation.
is 12.
Actually, 12 it is. Answer.
So is 4P2 wrong?
4P2 is correct, I believe.
Okay.
What is the value of 4P2?
12.
12.
Yeah, so it's correct, right? When you do 4C2 into 2 factorial, that is ultimately nothing but 4P2 only.
Okay.
So it's the same approach only. It's just when you do it through combination, you get a better clarity of what's happening. That I need to select 2 flags to make the signal. And then I have to also contribute about the arrangement. This whole picture gets hidden when you write 4P2. But ultimately both are same. Okay. Or else you can go from the first principle, that is 4 into 3, this part also. Is that clear?
Yes, sir.
Okay. So let's say
Excuse
the
me,
same
sir.
way. Yeah.
Sir, can the answer be changed based on the question?
Sorry?
The answer might change based on the language of the question, because it means only 2 colors are required for making the signal, or the sequence of the color is required.
Okay, see, it depends on how you want to interpret it. For example, any flag in general, if there are, let's say, this is what I'm making a signal. In general, in common term, it should be what? That if this part is blue, and let's say this part is pink. Okay. This is obviously a different flag than finding out another flag where the top part is pink and the second part is blue, right? These two are distinctly different things, correct? In general, if they are mentioning it exclusively something that order doesn't matter or not, it's a different case. But in general, these two are different flags altogether, right?
In this case, for the combination of 2 flags, here what you are explaining, I think, is become the only flag. But when we are combining 2 flags to make a signal, there does the order matters?
No, the combining thing, the order doesn't matter. That's why we have taken that 4C2 part first.
Okay.
That is, we are taking only selecting 2 flags. After that, because order matters, that's why we are multiplying 2 factorial.
Okay, thank you.
Okay, so next, this is one kind of where we are taking about symbols and all. Let's try that out with letters also. Okay, so let's say this is the word success. What are the possible ways you can arrange, means different possible words you can make out of it? Anyone?
7 factorial by 2 factorial by 2 factorial.
7 factorials by 2 factorial into 2 factorial. Anyone any different answer?
Sir, 3 factorial, sir. Divide by 3 factorial into 2 factorial.
3 factorial, sorry. 2 factorial into 3 factorial, sir.
The 3 factorial it is, yeah.
Yeah,
Okay,
I missed that part.
computing. Okay. 7 factorial by 2 factorial, 3 factorial. Yes, because in general, if this all would have been distinct letters, then it would have been in general 7 factorial. So this is a recap of that if you have not all the objects are distinct. Okay. So these two are, if I have to mark it out, that these two C would be similar C and this 3S would be similar S, right?
Yes, sir.
So we'll having 3S and 2C, which are similar. So it doesn't matter to us how this, let's say S1, S2, S3 are arranged in whatever possible is, it will ultimately, when we are framing words, it will be the same. So we have to remove this part out of it. That is 3 for the 3 factorial for this 3 similar S and 2 factorial for this 2C. Now, if we have to modify this question, we'll try to get what? Dictionary problems. Okay. So let's say dictionary problem. Can you tell me in dictionary, what would be the rank of success? Just it would be a lengthy calculation.
What do you mean by rank of success, sir?
At what position should rank, at what position would success occur in the dictionary? So basically, whenever there is a dictionary problem, you have to find out that you have to arrange alphabetically all. And I think this would be a lengthy calculation. I just want a rough, whatever would be your approach.
So
Anyone?
what success?
For the word success.
Oh, okay, sir. I thought you are trying the Bernoulli thing.
No.
So we will first check all the possibilities for C, then
Yes.
E.
So alphabetically, first letter that comes is C, right? Now the catch over here is that will I take 1C or 2C?
Sir, both are same.
Okay.
So we can.
6 factorial.
Okay, just any tell me what are the different answers you're telling for let me fix in the first position. So it is like 1, 2, 3, 4, 5, 6, 7. There are 7 positions, right? So out of 7 positions, I am fixing at the first place C. Then say
6 factorial by 3 factorial.
Factorial.
Okay, how many are saying 6 factorial by 3 factorial? Can you just raise your hand? Okay, only out of 50 people, 6 accept this.
Sir, 6 factorial by 3 factorial into 2 factorial. Divide me, sir.
Okay, Sanjoli has a different answer. 6 factorial by 3 factorial into 2 factorial. Okay. Okay, let's first take the voting for 6 factorial by 3 factorial. Then we'll go for the 3 into 2 one. So for 6 factorial by 3 factorial, how many are voting? Only 6. Okay, 5. The question says that there is a word called success. The letter you have to arrange all possible letters, all possible combinations or all possible words that can be formed out of these letters, fixing C at the first position.
Sir, what will be 6 factorial?
1,
Because even though there's repetition,
720.
order matters.
No, are you asking about the value or what? How to interpret 6 factorial? What are you talking? Or you are saying that the answer will be 6 factorial?
No. I got it.
Okay. Okay, so 7 people are saying for 6 factorial by 3 factorial. How many are going for 6 factorial by 3 factorial into 2 factorial? Others just drop down your hands, and who are supporting this, only they should raise them. Okay. Sanjali, only you are voting for yourself. 6 factorial by 3 factorial into 2 factorial. Okay, no one is voting.
So others were also voting for Sanjoli's answer, but they pulled their hands down. Sanjoli wasn't alone.
Okay. They changed team at the last moment. Okay, so basically, when you are talking about C, ultimately there are two C's. It's okay. But let's first talk about the numerator part. In numerator part, we'll take these all as individual objects. That is ideal case. So it will be in general, how many factor? What would be the factorial if you are fixing C? It would be, I'll be having
6
U,
6 factorial.
one C, one E, and double S, right?
You are arranging 6 out of 6 of thing. 6p6.
What I'm arranging out 6 out of 6? No. I'm talking about the letters. Which letter did I miss? U, C. Okay, there is one more S. So I'll be arranging this this 6 letters, right? That would be done in 6 factorial. And at the below, in the below, I will be having this 3 as my. So in the denominator, I'll be having only this 3 as my not unique objects, which I have to take care of. That is 3 factorial, because ultimately I fix C, right? So whatever the possible arrangements I'll be making, let's say it can be, one can be like C, and then this is C, U, E, let's say SSS. Another can be C, and then again can be U, C, E, SSS. So this way we are not considering this part. Ultimately only we are considering this part, right? So in this part of my means possible arrangements, I'll be having only one C, right? So we need not consider that part. So this is where people can get confused that to include that part or not. Okay. And similarly, we'll consider for E, because after C, what would be in the alphabetical order? It would be E, right? And for E, it can be done in general way. It would be 6 factorial by 2 factorial into 3 factorial. What we were doing for the earlier case, the confusing case, because 2 factorial would be for the 2 C's and 3 factorial would be for the 3 S, right?
Yes, sir.
Okay. Now the catch comes that after E, what should we arrange? We'll be arranging S, right?
Yes, sir.
Now, when we are talking about S,
U comes before S, I think.
No, that's really fine.
Okay.
Sanjay, you can go and learn ABCD once.
Sorry, sir.
No, I'm just joking. Okay, so basically it happens. So after S, because it is already included in success, so what should be our approach? Because if you are including every letter after S, means fixing S, if we try to do in the similar way, that is 6 factorial by, ideally it would be 2 factorial into 2 factorial, right? But in this case, what the possible problem that can occur is, we'll be also arranging some letters which would be after success, means some possible arrangements which would come alphabetically after success also, right? So we have to be very cautious about that part. So ultimately what we'll do, we'll see that are we getting something like U, or before that are we getting any individual letter which is alphabetically below SU. And that would be obviously C, right? So we can fix SC and that comes before SU. So we will try to take all the possible arrangements of SC and then we'll try to find out all the possible arrangement in this case. So it would be SC, and then for this part it will be 5 possible ways, right? So in this, for this case it would become what? 5 factorial divided by what would be the answer?
2 factorial divided by 2 factorial.
Only 1 2 factorial.
Okay. Yeah, 1 2 factorial. Yeah.
Okay, is it clear to all? Why it will be only 1 2 factorial, right?
Yes, sir.
Okay. And similarly, I think we'll not waste more time in this. Similarly, for SE also we can do it same way, and then there will be SS, and then we'll go for SUCC. So you have to do it systematically one by one. Okay.
Yes.
Now I think one more kind of case. I think in your last quiz also you got one question, if I remember it. There was one number question, right?
How many numbers, 3-digit numbers, can you make from 2 different digits from 1 to 9? That part? That question?
No. That
How many
divisibility.
nines?
How many
Calculate how many
nines?
nines from 1 to 1000.
The 9, calculating the 9 part, that is easy, right? You have to just find out So all the possible in 1-digit places, how many 9s you are getting, in the 2-digit places, how many you are getting. I think that would come out something 300 or something.
Yeah,
That
300.
300 was the answer.
I think so. I think Chetan and all were discussing this also in the one of the sessions.
Yeah, we were discussing.
This is kind of, you have to do, there is no means definite trick to this. You have to just segregate into different sections and then try to calculate all the possible.
Okay.
But I was talking about the divisibility. I'm just trying to means cover all the pattern of questions that can come in PNC. But yes, one thing I would like to give a disclaimer that PNC would be a very least weightage in the interim paper. Okay. So
Tough
if
also.
somebody, sorry?
Tough also.
Least weightage.
The weightage of number of questions from PNC would be least compared to other topics. Okay. So somebody who is not comfortable with PNC also can score very good marks. So that way means start preparing. Okay.
So the more focus is on distributions and the first 4 weeks.
First 4 weeks.
The last 4 weeks.
I think
Week 12.
Yeah. I think you all would have received a mail, right, about the weightage thing.
Yeah.
From
Yeah,
last
9 to 12, sir.
Yeah. So according to that only, basically it would be more focused on probability and distributions only. PNC, you may get a few questions from PNC pathways.
What about 1 to 4 weeks, sir?
That will also be very, means maybe there will be a few questions from that. But as I said, most of the questions, maximum to maximum questions will be from the last part. Okay.
Are those going to be simple ones from 1 to 4?
Now, it is a very difficult question to answer that which is simple for. Okay. So, we'll not get
What
into
about the geometric distribution?
Geometric distribution, the content is not yet uploaded in the additional content part. It would be done by most probably max to max tomorrow. And in the tomorrow's session, I think the next session is scheduled for tomorrow, right? Revision session.
Yes, sir.
Yeah, so we'll bring in 2-3 questions. So to give you a rough idea about how to go about this geometric distributions. Okay.
Yes, and what about normal distribution also should we learn?
No, you can ignore normal as of now.
Okay.
If you have interest in learning, you can do it. But in general, you will get to know detailed about normal distribution in stats 2. Okay.
सर खुद का ही नहीं हो कि तेरा इंटरेस्ट तो अगला जब जागेगा ना.
Okay. So next pattern of question can be about the divisibility. I think this was also one of the questions in quiz, right? So that let's say it is divisible by 4. So in this kind, so in this kind of questions, what you have to do, you have to fix in the last 2 digits all the, let's say it was let's say we'll include 0 in this case, 0 and let's say 2 and let's say 4 and let's say 9. So what are all the possible numbers that you can frame out of this which are divisible by 4?
0, 4, 2, 0, 2, 4.
2, 0, other can be 2, 4, correct?
9,
Anything
2.
Else? 9, 2 also.
3, 2 also.
No, we don't have 3, only 0, 2, 4, 9.
Okay.
So now once you fix all these possible cases, then you have to find out for the other, if it's a 4-digit number, and then in these possible cases, what are the all possible combinations or arrangements that you can make. Now in these cases, one more thing you have to be cautious about, that in these 2 cases, in this case only, these 2 cases, these 2 cases, what you have to see, that in the first place, you can't include the 0 part, right? So in the first case, what would be the possible possible arrangement?
Sir?
Yeah.
Sir, is there repetition allowed?
If you want to add, these are just I'm giving you all the patterns. If you want
to, there would be 4 also.
So tell me for this case, in the first 3 into 3, right?
Yeah.
Okay, 3 into 4.
Yeah.
Correct.
Repetition allowed. Yeah. Yes.
Repetition allowed. So it would be 3 into 4, right? And in these cases, it would be in general 4 into 4.
Sir, if there is repetition allowed, then there should be also 4 in last 2 digit.
Correct. That also we can take. If
Yes,
repetition
sir.
allowed, then 4 also we can take.
40.
And also 40.
40.
40 in last
40
2
is also there.
Correct. 40 also we can take. Anything else? I think you covered all the cases, right?
Yes, sir.
In this case, do we have to take 0 as well? Like 24, when 100 is divisible by say 4. So how would we know?
No, we have to only include this digits, right? We can't take
So we
other
have
than
0, 0.
Sir, is repetition allowed? If repetition is allowed, 0 would also be there.
you can take 0 also. But if you are including 0, then will there be any constraint on the first two part?
No.
Yeah, it will have to be 3 into 3.
3 into 4. Maybe 3 into 4.
Okay, so let's take this part only. I think other parts are straightforward. So for this case, if you are taking 0, tell me for these two parts, what would be the numbers?
3 into
For
4.
3 would be there. 4, 1, 4.
This would be 4, right?
Yeah.
No, but it depends. I mean,
32 okay, yeah.
Like will 9 and then 9 to 0, 0. Is this divisible by 4?
Yes, sir.
Yes.
So basically any number which would have this last to 0, 0, I think all would be divisible by 4, right? Because yeah. So it won't have any other constant. You can directly do 3 into 4, correct?
Yes.
Yeah. So this is one more pattern. Okay. There is one more pattern of question. I think somebody asked me also in one of the sessions. We'll try to, this is also kind of repetition. So let's say there is a grid given to you and this is a grid. Okay. So in this kind of a question, let's say this is part A and this is part B. And I am asking you what is the possible, to all possible ways you can reach from A to B. And always you have to take either a horizontal path or a vertical path. You can't take diagonal paths. Okay. So like, for example, your one path can be this and then this and this and again this, let's say full and this. This can be one possible path. In this way, how many possible paths can you find out so that you can reach from A to B? Anyone?
The
Whoever
question
asked,
is not clear.
8 factorial divided by 4
Can you repeat
factorial
the
divided by
question?
4 factorial.
Hold on. Other than Chetan, others will try out because I think Chetan, you only asked this, right?
Yeah.
Okay. Other than that,
n factorial upon n factorial into n factorial.
Okay, I'll just explain the question once more, then we'll go for the solution. For those who didn't get the question, I'm talking about that this is a grid given to us. Okay, this is a particular grid given to us. Now, someone, let's say from here, starts his journey, and we are saying that from this, okay, so from this part, they start their journey, and I'm saying that either they can move this way and then this way, again this, and then this can be a particular path, right? This can be a particular path and I can reach B. There can be another path where somebody can go this way and then this way and this way, this whole way, and then go this way. But there can't be a path like where you will go this way and again, let's say this way and again this way and then go this and this. So all your possible paths would be either you take a horizontal step or you take a vertical step. This way, how many possible paths you can make that you can reach till B? Is the question clear now?
So you only can move to the right or to the up, right?
Either you can move to your right or you can move up. That's it.
For first one, it would be from A to B. It is basically taking 8 steps.
Sorry.
However, it is work from position A to position B. It is taking 8 steps.
Okay, correct. Then okay, this is whoever who.
Sir, can you move left?
No, 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 no. You will only be moving in your forward direction. So yes, whoever said this part, it's correct that others who are not getting how the clue how to solve it. This is a means the biggest clue that I can give, that it any path you follow, it will be always 8 steps. Now, how can you proceed? Sorry?
4 steps right and 4 steps up.
Yeah, 4 steps right and 4 steps up. Okay.
So that would be 8 factorial, right?
Okay, someone is saying 8 factorial. So this is your final answer, 8 factorial?
And
okay, we'll see. Others, anybody, any different answer other than 8 factorial, you can attempt.
I think it might be 4 times 4.
It is 8 factorial upon 4 factorial into 4 factorial.
8 factorial into 4 factorial. Okay. Any more answers?
8 factorial divided by 4 factorial into 4 factorial.
Okay, okay. 8 factorial divided by 4 factorial into 4 factorial. Any more answers? Okay, let's try to break this down a bit more. Okay, over here, let's say we had this is one. Okay, so let's say one process can be one path can be that you start this part and then you take, let's say, this path and this path over this and this and this. Now tell me, in this, how many horizontal paths you have used and how many vertical? Anybody?
4 horizontal.
1, 2,
4.
3, 4. Right. So let's say 4H, and then there are 4 verticals.
4V
1,
vertical.
2, 3, 4. So let's say 4V. Right. Now let's take another path. Let's take another path. Let's say this is my path, and then this is the path, and then again this path, and then we follow B. Again, can you just tell me how many horizontal or vertical you have taken?
Same 4 and 4.
Same 4 horizontal and 4 vertical. Right? So this is the observation that we need to do. That whatever we do, whatever possible way we can follow, always will be having 4 horizontals and 4 vertical to pick up. Now, can anybody try it? Like, what can be now the modification in your answers?
So we don't have to choose in this question. We have to just arrange. So we can do like 4 factorial into 4 factorial.
Initially, someone said that any possible path we take, this is 4, 4, but whatever it is, we'll always be having 8 paths to take, right? So, like for example,
the basic step that from position A to position B, it will take 8 steps.
Correct.
So everything can be done in 8 factorial ways. Now, now this can be terminated, break into 2 parts, because it is taking 4 steps rightwards, 4 upward, and 4 steps rightward. So it will be 8 factorial upon 4 factorial by 4 into 4 factorial.
Okay, we'll see. I'll just try to interpret in a different means. Okay, whatever, whoever said this answer, it's correct one. Okay, so ultimately the answer would be 8 factorial by 4 factorial into 4 factorial only. Now you can think it this way, that there are 8 letters you want to arrange. Okay, so it can be like all these horizontal things. I can tell it like H1, let's say all H only. Okay? Not to just confuse. There are 4H and 4V. That is the interpretation we can take, right? And that arranging this, I can make it like that there are 4 V's and 4 H, and I am trying to find all possible arrangement. Now that would only give me the possible ways, like if I'm taking first a vertical step, Let's say one arrangement can be V, H, then again V, then H, H, and then again V, 3, 6, 7, and then H. Right. So this can be one path for us, right? That I'll be taking one vertical, then one horizontal, then again vertical, then two horizontal, and then two vertical, and then a horizontal, and I'll reach B. So ultimately what it is done in 8 factorial ways. And then this all vertical steps or the horizontal steps, they're all similar to each other, right? Over here, if you can see the arrangements. So for that, I'll be needing 4 factorial into 4 factorial. Is this clear to all?
Yes, sir. Yes, sir.
Okay. So this can be one kind of a question. And I think there was one more question from this permutation. Like for example, one can be that, let's say there are given 6 men. Okay. One kind of question left to pick up and making groups. Let's say there are 6 men and 7 women. Okay. And I'm saying you that you have to make how many possible ways you can make couples of make a 4 couples, let's say. So what do you, when I'm talking about couple, how we are defining it? It's like there will be 1 man and 1 woman. Okay. Now I have to make how many possible ways you can make 4 couples. Anyone? How to approach this?
So we need to make 4 couples out of 6 men and 7 women.
We fix women, and for each woman we select men.
Choose 4 men out of 6. 6C.
Okay, 6C4. Then
we have to arrange. Means select.
Select women also. 7C4.
7 into 6 into 5 into 4.
Okay, whoever is saying this, just one by one, can you all tell your answers? Like whoever was saying the 6C4, start. Yeah, can you just complete your answer? Then we'll go to the other part.
7 into
6C4, then 7C2.
7. No, C2. No, 7. We have to couples. No, sir. For all the 4, we should have one wife. Means each should have one wife. For that, we have to select from the 7. Means 7 into 6 into 7P. 7P4, sir.
Okay, 7P4. Then?
That's the answer.
Okay, that's your answer. Okay, anyone else? Any other answer?
Yes.
So what is the question?
There are 6 men and 7 women, and we have to find out all possible couples that you can make out of this means this many people. Okay, a couple is that you have to make a group of 1 male and 1 female, or 1 man and 1 woman, basically.
So you can do it like 6C4.
So one couple only.
No, all possible couples we have to make.
Okay.
6C4 into 7C4 into
4 factorial.
Oh,
it will be into 4.
See, these are 2 ways to think about it. I think first who said this answer, Priya or somebody.
No. I think.
No, it is correct. So what you do is you select 4 men out of 6, then you select 4 women out of 7. You fix the number of men on those 4 places, and you permute the number of women in 4 factorial ways. So that's correct, I think.
Yeah, exactly. That is the whole approach to this. This is also correct, or you can do this way also. It's correct. The same thing. Okay. If you have to break this down, then only maybe it's a better approach. That when you take 6C4, let's say you have find out M1, M2, M3, and M4, right? Now you are also selecting 7C4 from 7 women. You are finding out 4 women. So let's say it is W1, W2, W3, and W4. Now for first M1, how many possible ways you have? You can have 4 possible women, right? Now, once you have fixed someone or allotted someone to M1, then for M2, how many possible choices are left? That is 3. Then for M3, how many choices are left? 2. And then for 4, it is 1. So ultimately, this 4 factorial comes, or you can do it, whoever can get that idea, then 7P4 is also a right approach. Okay.
So, but we have like 6 men and 7 women. So we have 7 choices for one man, right? Why are we taking CC4 or 6C4?
Because ultimately we have to make 4 couples.
Okay,
So
okay.
there will be only 4 girls who would be involved in making couples, right? And then you can make different couples among them.
Okay.
Is this clear to all?
Okay, sir.
Yes, sir.
Okay. So basically one more just point to be cautious about, that whenever you are using this NPR formula, keep in mind that only use it when you have distinct objects. Okay. If you don't have distinct objects, don't just blindly apply this formula. Then you will be getting wrong answers. One more thing which I wanted to talk about.
Sir, can you do one problem on distribution of like objects? Is that part of the exam?
You won't be getting questions from the distribution and grouping of this like objects. There won't be possible questions from those, because I don't think they were covered in the lectures, right?
Yeah, they were not. Okay.
Can I ask anything from the quiz too?
The PYQ, right? Or you are talking about the previous quizzes, or you are talking about specific?
Previous quizzes, sir. Quiz 2, the very first question. How many 3-digit question numbers can be formed using 2 digits out of 1 to 9?
Okay, I'll discuss that one also. Okay. Basically, okay, just give me a second if I'm missing out something, any point, or else I'll go to that. Okay?
Yeah.
I think normal factorial, these parts are pretty straightforward, right? Anything in this part, there is nothing to discuss. Any total arrangements, NPR, anyone who have any doubt in NPR or means in general NPR or NCR formula, how to means not getting the intuition part of it? Anyone? Okay, so yes, whoever was asking that question, there were there were 3 numbers, right? Or 3 letters?
3-digit numbers.
3-digit numbers from 1 to 9 using 2
From 1 to 9, you have to choose 2 digits out of 1 to 9 using 2 digits. Repetition is allowed.
I have to choose 1 to 9, and then out of that I have to make 3, means from I have to pick from 1 to 9, I have to pick 2 digits, and I have to make 3-digit numbers, right?
Yes, sir. Yes.
Now, and it is saying that repetition is allowed.
Yes.
So repetition is allowed for which number?
So the question was, how many
just read the question.
How many 3-digit numbers can you make using 2 different digits from 1 to 9?
Okay, got it. So basically, let's try to break it down and try to solve it together. Okay. First thing is, out of 1 to 9, how many possible? How many digits we need? 2 digits. We can choose 2 digits, right?
So 9C2 ways, yeah.
Yeah, correct. Once we have, let's say, these 2 digits are, let's say, 7 and 8. I have chosen 2 digits. Now what it is talking about, that I have to make 3 digits number. Now, when you are talking about 3-digit number, obviously there will be repetition, right?
Yes, sir.
Else we can't make 3 digits. Yes.
2 cubes, sir.
2 cube. Okay, so you are saying. So you are saying 9C2 into 2 cube, right?
Yes.
So what would be the answer? 9 into 8.
It would be.
This part would be 8. So 72 into sorry, this part would be 2, right? So 4. 36 into 8. So it would come out to be
288. Incorrect.
288. No. 288. That is okay. But whoever said this 2 cube part, can you tell me the logic behind this? Why are you taking it 2 cube?
For each position, sir, there is
each position we have 2 options, right? This way you are interpreting it. Okay.
Yes, sir. Yes.
Not exactly this is how we'll be doing, because what happens in these cases, can anybody tell me what is the drawback in doing it this way?
It's over counting. If the numbers are repeated, then you're counting it extra times.
So there should be 2 square, I think.
There will be 2 cases where all digits will be same. That is 777 and 888.
That's right.
One by one. Everybody, you can explain your solutions. Whoever wins, I'll give you chocolates. But please don't.
Online
So out of
chocolate.
those 8 cases, there will be 2 cases where all the 3 digits will be same. That is 777 and 888. We don't need those.
That's right, sir.
888. Okay,
Yeah.
these two we are over counting because when you are saying that is 3 possible option. I can say that if I'm choosing that this place can also have 7, this place also 7, this place also 7, right? Because ultimately for each position we are saying that there are 2 choices. So and this is also possible. So we will be kind of over counting. Whoever was saying this 2 cube part, did you get it?
No, sir. Can you explain it?
Let's say, for example, I'll do it in the 1-0 part. I think that is the best way people understand. Let's say there are 2 digits, 1 and 0, and you have to make, let's say 3 possible, not 3, let's put it 2 only. So what are the possible ways you can make it? How many possible ways? In the first place, you can put 1 or 0, that is, sorry, 2 possible ways, and in the second place also 2 possible ways, right? So 4 possible ways. Now, can you tell me all these 4 possible ways, what you are making? It can be 1 1, it can be 1 0, it can be 0 1, and it can be 0 0 also. So when you are taking it for one first position, 2 possible ways, it can be either this one also, and this second position can be also 1, right? You are not putting any constraint that if I chosen in the first place 1, my second place can't be 1, isn't it? Whoever was asking it, are you getting it?
I mean, yes, sir. Repetition is allowed, right?
Repetition is allowed, but if you are doing 777, then you are not using the other digit, right?
Okay.
We have to ultimately use these 2 digits. That is for sure.
Oh,
and
okay,
then
sir. Okay, sir.
Okay, no?
Okay, got it, sir.
Yes.
I thought we can. Okay, got it, sir.
Okay. So then, how can we modify this 9C2?
It's going to be 3 factorial. It's going to be 3 factorial, I think.
9C2
into 3 factorial.
So 2 cube minus 2, I think.
Yeah, that is correct.
The same thing. 2 cube minus 2 is just because you could find out that what are the possible cases, you did it. That's okay. But in general, whoever
So,
said
2 square, right? 9C2 into 2 square.
But tell me, like, how are you doing it? It's like you are doing reverse engineering. You know the answer, and you are trying to find out what are the possible ways you can get that answer. But why are you saying 2 square? Tell me the
2 square. Basically, sir, any one of out of 3 position, any one position will contain one of those, and the other 2 positions will have 2 options.
Okay, that is also a fair way to think about it. I'll not say it's wrong, but I think a better way to think about it is that out of 9C2, okay,
so
once you are, yes.
Yeah, no, I was just explaining that for 3 factorial, you first select one of the numbers, and in the remaining 2 places, you put the other number. So that's 3 factorial upon 2 factorial. And then you do the same thing for the other number also, which is again 3 factorial plus 3 factorial. So you have to multiply it by 2 so that you get 3 factorial then.
Oh, but isn't this a easier way that once I've chosen 2 numbers out of 9 possible numbers, now out of 2 numbers, because it's kind of given to us that there are 2, I have to use 2 digits, right? So, and I have 3 places. So compulsory 1 digit will be repeated. So out of these 2, I can choose 1 digit which I want to repeat. That can be in 2C1 ways.
Correct.
Can I do that?
Yes.
So there are different approaches to it, but I'm just trying to find out which is kind of more practical to us.
Okay.
So once I've chosen 9C2, then I can choose 2C1. Now I have already got, let's say, if I've chosen 2 numbers, 4 and 7, let's say I have chosen 4 to be multiplied, means repeated twice. So I can have 4, 4. Now this part, 7, this can be I can place it in all three possible places, right? That can be done in three possible ways. Because it can be this, all these possible cases can happen, right? 7, 4, 4, and the other can be 4, 7, again 4. Only these three possible options are there, right?
No,
Yes,
I did not get it. So the first position you fill it in 2C one way. The next position for the next two, you have to select the other number, for example. So you selected any of.
This is not first position. This is one number out of the two numbers which I can, which will be getting repeated.
Okay.
Because out of 4 and 7, I am choosing one number which I can make it to repeat. Like so, this is the number I am choosing. That let's say I'll
Okay,
allow.
I got it. So you select 2 out of one number and then you permute it in.
I'm just permuting this number, which is the single digit.
Got it. So you permute it in 3 factorial, but then because there are 2 numbers repeated, you again divide by 2 factorial. So that. Okay,
Correct. Yeah, you can interpret it that way also. That you are permutating 3 factorial, then you will, because one number is repeated, you can do 2 factorial, right?
Yes.
You can do it that way also. So whoever was asking.
Sir, can you please explain again after 2C1?
Can we formalize this? I mean, such cases, can we formalize this?
Formalize, like what? Yeah, both things you can formalize only, right? It's in general, this is how we do basically. Like for example, once I do 9C2, basically I'm saying that I've chosen 2 digits.
Yes.
Now, once I've chosen 2 digits, that is, let's say 4 and 9. Once I've chosen 2 digits, because I have to fill up a 3-digit place, I can't do it just by placing one number once, right? I will have for sure one number has to repeat. Then only I can permute them and make 3-digit number.
Okay.
So either my numbers can be that 4 is getting repeated, or my numbers I can have numbers where 9 is getting repeated, right?
Okay.
So out of these 2 numbers, I'm choosing that number to be which number I want to repeat. That can be done in 2C one ways.
Okay.
That is 2 possibilities. That is, once 4 can be chosen, once 9 can be chosen.
Okay.
Right. Once you are done with that, let's say you have chosen 9 to be the number. So if 9 is fixed in 2 places, then the other number can be alter changed in 3 possible cases, right?
Yes.
Because let's say 9 and 4. 4 can be in this position. In some cases, 4 can be in this position also. And in some cases, 4 can be in this position also. That is, when 4 will be in this position, let's say, then ultimately the other 2 positions will be filled by 9 this way. If let's say 4 is placed in this position, then the other 2 positions can be filled this way also.
Okay.
So there are ultimately for 4, we can say that there are 3 possible places where I can fill 4, right?
Okay.
Is this clear?
So sir, there can be 944, right? There can be an option like 944.
Yes, that part would be encountered from this part, right? 2C1, which I'm talking. Because these are all the possible cases where I'm considering 9 to be repeated. Now there will be another set of numbers where 4 would be repeated. Okay. I mean, this part would be, did you get it? Means
yes,
there
yes,
will
sir.
be a set of numbers where my 9 is getting repeated. For example, this, okay, I'll just break it down in total then maybe. Let's say first thing is I am choosing 9 and 4. Okay. Now out of this 9 and 4, there will be cases where 9, I'm getting 9 and 1 4. And there can be one case where I'll be getting 4 and 1 9. So when I'm now, after I'm choosing these possible options, it can be 9, 9 and 4. There can be 9, 4 and 9. And there can be 4, 9 and 9. Similarly, when I'll be doing this part also, it can be 4, 4, 9. This part would be 4, 9, 4. And this part would be again 9, 4, 4. Right? So this part, this is this part, these 2 parts is taken care by 2C1. This part is taken care by the multiplication of 3. And this choosing of 9 into 4 is taken care by 9C2. And then we are multiplying all of them. Is this clear to all?
So we can think of it as a coin tossed 3 times, and we have to just take the without like 3 should be not all heads or not all tails, right?
No, then if you're doing it that way, you have to take the means consider two like objects. Okay, somebody was saying that dividing by 2 factorial, no? Okay, because coins, when you consider coins, they are all distinct, correct?
So
it's
this,
yes.
So this scenario, I mean, this concept or this issue has to be considered whenever the repetition issue will come, I believe.
Yes, correct. Whenever there is a repetition, you have to either divide it this case and or this way. This is a different approach altogether. We are saying that we'll consider that I'm choosing a number which I want to get repeated, right?
Since we have to make the 3-digit numbers with two different digits, which are chosen from 1 to 9. So you have to fix one digit as 2C1 and the rest of the options you are giving it as 3.
Right.
Okay.
But you'll have to figure out why it is 3.
That you have to see this. This thing should get into your head during the exam, that why it is 3, because ultimately this is the option. This is the letter which you can place in the 3 different positions, right? Or the simpler approach someone was saying, right? That I can do 3 factorial, 2 factorial.
Yeah, so what you can
into 1 factorial, right?
Yes, yes.
So what you can do is you select, so there are 2 digits that you have to use, right? So you select one of them, say in 2C1, and you say that I'm going to repeat this one. And then you place that, so you have two, now you have 2 places in which the digit is repeated, in the first and the second place. And in the third place, you get the other digit that did not get selected in 2C1. And now you permute it in 3 factorial ways. And because there are 2 digits which are similar, you divide it by 2 factorial. So that's how you get 3.
Yeah, right. For this 3 part, we can actually interpret it this way, or in general, if you want to means get a visual thing, you can get idea from this also. Whatever is the means, whatever is easier for you, you can think it. Okay. Is this clear to all?
Yes, sir.
Okay. So I think that all covers. We have already covered the dictionary problems. We have also covered.
There was a problem.
Yes.
There was a problem in the.
So we can discuss something on the circular permutation. 1 or 2 questions.
Circular permutation. See, the basic idea about circular permutation is, as in general, when you do a linear arrangements, let's say over here it is, let's say 5 factorial we do, right? Because either we'll be arranging from the left side or we are from the right side, we have a base. Whenever we are doing circular arrangements, there can be cases where I have to fix one base position and then the other positions I will be arranging. So it can be done in n-1 factorial. Now there are different cases, or the typical cases which comes out, that let's say you are finding out that no girls should sit together or no boys should sit together. Those are the cases. In those cases, what you will do in general, you will be either fixing the boys first, and then in the gaps, whatever you used to do for the linear cases, similarly we'll do for the circular cases also. Just we'll be considering the this base, the reference we have to fix. That's it. The rest part would all be similar way. Okay.
And the beats one.
Sorry.
n-1 by 2 beats. Somebody was asking in the chat. They have problem in this round table sitting arrangement.
Round table sitting arrangements. Okay, so let's take a question from round table arrangement also, if you want. So let's say.
Sir, actually in the lecture there was something division by 2 also. Can you explain that too?
The division of 2 parties, because there will be some cases where all the objects are similar to each other. Okay, let's say for example, when you wear a necklace or something, all the beads are of similar to each other, right? So in general, when we do, let's say for example, this is a table. This table is distorted. So let's say over here, let's say Ram is sitting. Over here, Ali is sitting. Let me write it. Ram, and over here, Harry, and then over here, Sham. And now let's say there is another case where I'm saying, similarly, Ram is over here. That is my anchor, right? Which I was doing in n-1 factorial ways. Similarly, over here also Ram is there. But the difference that comes out is this, towards right of Ram, Ram not towards the right of Ram, Ali is there, and towards the left of Ram, Hari is there, and in the front Sam is there. Now, is these two arrangements same or different?
If the thinking clockwise and anti-clockwise is different, then it is different.
Yeah. So these cases, you have to take these cases to be different. Why? Because ultimately, you can this all the if they're persons, they're all identical, right? Means you can identify them differently. They're not identical, distinct objects, distinct people, right? So Ram, in this case, this is a different arrangement because you can say Harry was sitting to right of Ram. Over here, you can say Hari is sitting to left of Ram. So these two are different arrangements. But when you are talking about similar objects, that is, let's say in the case of necklace or other different similar objects, these two conditions won't be there. That is, if I'm flipping it, it is ultimately nothing but it's like flipping in front of a mirror. If you see in front of a mirror, if you find it out, your right becomes left and left becomes right. So in general, that case you are trying to avoid in case of similar objects, because for similar objects, if this would have been instead of Ram and Hari, Ali, Sam, if I would have said that these four are just apples, they are exactly looking apples or balls, something like this. So this case and this case, it would have been similar, right? So for those cases, I will be just dividing it by 2 factorial to nullify that that I'm not counting these two cases separately. Okay.
So, but in nature there is no similar thing, like everything is different. So why we have to take this case?
No, we are. When I think that in the lecture it was given for a necklace, right?
Yes, sir, because it was handmade. Oh, sorry, artificial, human made.
Correct. So for a necklace, if you're saying let's talk about pearls or something, everybody looks similar, right? When you see it from the top, can you find out in the necklace which pearl is which one, or they all look similar?
Sir, in the lecture, it was only for the sitting arrangement of the people only, not like necklace, but still she divided by 2.
Then there would be, can you show me the question? Anybody like read out the question? Then there would be the part that these all are distinct or something similar. They would have mentioned it in the lecture.
Yeah, it was part of the lecture only.
Okay, I'll see. Just give me a second. I'll see that. But till then, I'll just give you in general question. You can just try that out. Okay. Let's say there are 5 boys and 4 girls in a circular table, and you have to find out that no girls are together. Just all try out this and see which lecture.
Five boys and 4 girls.
5
right?
boys and yes, 5 boys and 4 girls, and you have to find out all possible ways where no girls sit together.
So we can just fix one boy, and after fixing one boy, there should be like 4 factorial ways to arrange.
Don't tell me the answer. Just tell me the expression. Okay. Till the next.
Isn't it just 4 factorial?
Sorry.
4 factorial.
4 factorial. Okay. I'll note down all the possible answers. Then we'll discuss. 4 factorial. Anybody any more answer?
So 4 factorial into 4 factorial.
So.
Yes.
So 4 factorial into 5c4 into 4 factorial.
Okay. Any more answers?
I agree with someone. That's the answer.
Okay. So from this, all three possible, this is the right answer. Okay. Whoever said it, can you explain?
So I just said like we first fix one boy out of 5 boys, and after fixing one boy,
That comes 4 factorial. Okay.
yes sir, and then there would be 5 gaps in circle. However, things we take at a time, there should be equal to that gaps.
Hold on. So if I have to put it in a
Like
whatever,
there are 5 boys, so there should be 5 gaps between them.
whatever Sanjali is trying to explain, it is that once I fix, let's say B1, I can fix all the B boys, right?
Yes sir.
So now once I fix all the boys, that can be done in 4 factorial ways. There will be how many gaps, Sanjali? 1, 2, 3.
So 5 gaps.
No, so hold on. Is it so? I missed that 5C4 part, but shouldn't it be 5C4 into 4 factorial?
Yeah, correct. It will be 5C4 into 4.
But the initial 4 factorial won't be there, right? It says 4 factorial into 5C4 into 4 factorial. So the first 4 factorial should not be there.
It will be there for the arrangement of boys.
The boys, the boys will also arrange among themselves. Right? That is, hold on. I'll tell you. This part, that is B1. And let's say this part is again.
Okay. We need to permute the boys also in the circle. All right. Okay. Fine. Got it. Okay. So it's going to. So, but wouldn't it result in some sort of overcounting? For example, if you have say B1 and say next to B1 you have G1, which is the first girl. Okay. And then if say for example B1 moves to some other position, we are dividing by 5 to avoid that. All right. Okay.
Okay.
In a row, there should be 1 plus gaps, but in a circle, there should be equal gaps to that particular thing. Like we are just taking now boys, so there should be equal to that boys, the gaps.
Yes.
Because I didn't get it.
So basically,
there are 5 gaps for girls.
5 boys and 4 girls.
Yes, sir. I mean, there are 5 gaps for girls. So we should choose 5C4 into factorial 4 for girls also.
You are saying we'll choose 5C4 into
4. So to arrange girls between themselves.
So what is
factorial 4.
So only this you are saying, or means what is the answer?
No, multiplied by 5C4 into 4 factorial levels.
So that is only done, right? This part.
2 times.
So can you
explain
4 factorial part?
Can you just repeat it? Your voice is breaking.
Sir, 5C4 should be 2 times.
You are saying 5C4 should be 2 times into 2.
Yes, sir.
And why so?
Sir, 4 factorial multiplied by 5C4. This is all ways by which boys can arrange themselves. And then again, we are having 5 gaps for girls, 4 girls.
Hold on. Just tell me one thing. This first, let's break it down. This 4 factorial you are doing it for what?
For arranging boys between them.
Okay, let's do it. Then we'll move ahead. So let's say I'm doing B1, and then these boys would also arrange among themselves. B4, B3, and B5, right?
Yes.
Now tell me what is for this 5C4 for?
For choosing.
Placing the girls in between the gaps, right? So this is one gap, this is one gap, this is one gap, this is a gap, this is a gap. Now in these 5 gaps, I can fill up these girls. Is this okay? Hello?
And yes, sir. Sir, then we are not taking the permutation of boys.
Permutation of boys we already did, right? 4 factorial. We are arranging in them in 4 factorial ways, right? Let's say there were no girls, only boys were there. There were 5 boys. How many possible ways you can make them sit? Forget about girls, only boys. There are 5 boys. What? How many possible ways can you make them sit?
Yes, factorial 4.
4 factorial, right? No, 4 factorial, right? It's a round table.
4 factorial.
You can think about it as 5 factorial divided by 5 also.
Yeah. Okay.
So we are already considering the arrangement of the boys, right? Then we are inserting girls into those places, and then again this 4 factorial is for arrangement of the girls. That is, let's say G1 over here, G2, let's say G3 and G for this. So this 4 factorials, or this girls can also arrange among themselves also, correct? In all the 4 positions that you are selecting for these 5 girls, 4 girls out of the 5 positions. They will also arrange among themselves. So there will be separate arrangement of the boys and separate arrangement of the girls.
Okay.
Anything else?
No, sir.
Okay. I think it's already too late to, we have to also cover week 7 and 8. So from here on, Farhat will carry on with the probability part. Okay.
Okay, good evening, everyone.
Good evening, sir.
Good evening, sir. So you've done weeks 5 and week 6, I guess, right?
Yes.
Now let's go to week 7. Just a moment. Okay, so in week 7 and week 8, we'll basically be covering the basics of probability, right? As we've already seen, we've already gone through week 7, week 8 in the previous quiz as well. And we've seen the main topics that we need to cover in week 7 and 8 are basically what our experiment is, what is probability, then we'll be dealing with conditional probability, after that Bayes theorem and this total probability, right? So let's get started. I think it would be better if you would take questions rather than explaining this, since we have already gone through this, right?
So I have question.
Yeah.
So 1 second, I'm just.
Okay. In the meanwhile, would anyone volunteer to say what are mutually exclusive events?
So I got the question. A box contains 24 identical balls, of which 12 are white and 12 are black.
Okay.
The balls are drawn at random from the box, one at a time, with replacement.
Okay.
The probability that a white ball is drawn for the 4th time on the 7th draw is
white ball is drawn on the
white ball is drawn for the 4th time on 7th draw.
7th draw. So I won't. What I will tell you is how we will approach this question. From 7 draw, which means in the 6 draws, how many times did we have this white ball? White ball, it's talking
3.
about white ball, right?
Yes, sir.
In on the 6 draws, in the 6 draws, 3 times you had this white ball. You know the
Yes, sir.
probability of getting a white ball, right?
No, sir.
Probability of getting a white ball is 12 upon 24, right?
Okay.
Yes, sir. Okay. So you just take this into consideration, and This will basically what this will do is you will have to see what this is. This is right here. So you need to consider this. This will take care of the 6 draws, right? And for
Yes,
the
sir.
7th draw, you'll just multiply the probability that you got a white ball in the 7th draw as well. Okay, that will again be 1/2 or 12 upon 24.
Okay,
Okay.
sir. The rest
Okay.
of the 3 means the rest of the 6.
We
Like
don't care about those.
okay,
What,
sir.
like, they will definitely like, what is this 4th time on 7th draw? So we know 3 times it has been this white ball, right? So
Yes, sir.
obviously 3 times it had to be black balls, right? And we do not care about the arrangement in which they came. That is why we are dealing with 6C3, because it has just asked us what is the probability on the 7th draw. It will be the 4th time we'll get a white ball. Okay.
So we will have to consider for the rest 3 balls as well, right? From those set
Yeah.
balls that
Yeah, we need
those
to
are
consider.
So
Yeah,
it
now,
should be half to the power 3n.
what I will tell you now, we have gone through binomial and Bernoulli, right?
Yes, sir.
It would be much better if you do that in this in that way, right?
So, but I thought of doing. That's why I'm asking. We should do like 1/2 raised to power 6.
Yeah. Whichever makes you like, whichever method makes you do the question in a better way, and you are able to do approach it easily, go with that method. That is what I have been telling in session, those problem solving sessions as well. All the questions that we see in most of the questions that we see in week 7 or 8, when we complete all the 12 weeks of content, we see that generally we can categorize them in any one of the distributions, right? Either binomial,
Yes,
Bernoulli,
sir.
hypergeometric, right?
Yes,
So
sir.
basically what we are doing in week 7 and week 8 is we are preparing for week 9, 10, 11, because you will also come across this in stats too. All the experiments we perform, most of them 90%, you will be able to categorize it in a particular distribution. Okay.
Okay, sir.
First, you are seeing like in the first weeks we are basically approaching them with a like basic approach, and we are not dealing much about considering much about those distributions, but then we are studying those distributions in a little detail. Okay, so whichever way you feel it's comfortable for you, go
No,
that.
suppose this one, can you repeat this one? So I actually, the way I
Okay,
solved
I
it
think,
was like,
yeah, how did you solve this?
no, I took all the combinations. Like I took, like, there are 3 balls, 3 white balls and 3 black balls before the 7th draw, right?
Okay.
So there is one combination of that, and then for the remaining ones, you can take a combination, and that would become your event. And for sample space, then of course you can do all the different combination of 14 balls in sample space.
But like you're considering all the different combination, these permutations, orders.
Yeah, permutations of, yeah.
So,
keeping the 7th ball, keeping the 7th ball as black, and keeping the 7th ball as white, and 3 white balls before the 7th one.
Yeah. So I think there is one graded assignment question which is very similar to this one.
Yes, I
There
did
is
the
Sahir Khan question, right?
Yeah, I did it the same way.
Yeah, this is definitely a way to
There's
do this.
another question in the week.
Sir, one more doubt, sir. Sir,
Yeah.
can we not do it like, is this not the pattern of the questions of geometric distribution?
Geometric distributions, I don't want to, like, right now,
It's a modification of that.
I don't want to go into geometric distribution right now, but this is like you have seen that Zahir Khan question, right? I don't know how they. I don't know how what is given in the solution. If it is any different and you feel that method is easier than this one, you can approach it in that method as well. If this is comfortable with you, fine. Any method that you find comfortable, you can approach it in that way. Okay.
Yes.
Okay. So I think, yeah.
So I have a doubt in a question which was asked in quiz 2.
Yeah, I will take that. Basically, yeah, we'll get there as well. Okay.
Okay, sir.
So, sorry, just a moment.
Sanjay, what was the answer for that question? 0.1565?
Wait a sec.
Okay, now in this week 7, what we have gone through is mostly this basics of probability, the definitions, what a random experiment is, then types of events, mutually exclusive, and all those, right? So there isn't much to discuss from these, that these are just few definitions that you need to go through. Okay, let me see if I can take a question right now. Okay, so if we draw, let's take one start from a basic example. We have a deck of cards, 52 cards, right? 52 cards. And suppose one card is drawn at random. What is the probability that it will be a diamond? Yeah, 13 upon 52.
13 by 52.
Basically, what it is, favorable outcomes over total outcomes, right? These are favored, these are
It's
total.
5 by 32, Chetan.
Okay. So what I want you to do is remember this one. What we have like classic approach to probability is this one. Number of favorable outcomes over total outcomes, right? This is what we will be basically using in Bayes theorem as well, as I've already explained in the previous when we are taking sessions of quiz 2. This is what we will be taking in Bayes theorem as well. It gets a little confusing that we're not able to see how it is a favorable upon total, but I'll get to that part as well. Okay. So what is the probability of not a diamond? This was our probability of diamond. What is the probability of not diamond?
1 minus 13 upon 52.
Yeah, 1 minus 13 upon 52, or you will take all other cards as well. Yeah, whichever way you feel comfortable, right? That's 1 minus 1 minus probability of A equals probability of A complement, right? Or you can see what are my favorable outcomes in A complement. Okay, see, suppose this is a question. We have a bag that contains 9 balls. Okay, 9 balls, 4 are red, 3 are blue, 2 are yellow. This is these are the balls, and now one ball is drawn at random. Okay, what is the probability that it will be either red or blue? Anyone?
How many balls are drawn? Sorry.
4C1 plus.
How many balls are we drawing?
One ball.
That's 7 by 9.
7 by 9. 7 by 9. Okay. How did you get 7 by 9?
4C1 plus 3C1.
4C1 plus 3C1 divided by
Probability.
Probability
for the red ball is 4 by 9.
Yeah, basically what
plus 3 by 9.
Yeah, basically what if you are calculating this probability red or blue, right? Either it will be my red ball or it will be my blue ball. Okay, it is definitely equal to 7 over 9 as you all mentioned. So these are some basic examples from this probability. Now, okay, one more question that I have. Suppose we have a committee of 2 people, okay, needs to be selected. From 2 men and 2 women. This is what we need to do. What is my probability that it will be 1 man? I'll have 1 man in the committee. What is the probability?
So what?
What is the probability that in the committee there will be 1 man?
1 by 2. I think
Sorry?
it's 1 by 4.
1 by 4.
Yes, sir.
Okay. 1 man in the committee, what does it mean? There is 1 woman, right?
Yes, sir.
So from 2 men, you will choose 1 man, right? and from 2 women you have to choose 1 woman, right? And total we have 4 people, we have to choose 2 people, right? These are my favorable, these are my total, right?
Yes,
So
sir.
this is 2 into 2 over 6, right?
4 by 6.
4 by 6, or which is equal to 2 by 3. So this is for this question. 1 by, someone was saying it will be 1 by 2. Did you see where you made your mistake?
Yeah. So
okay. So now, sorry, if I change my question to that, the no man, what is the probability that there will be no man in the committee? What will this be?
2 by 6.
2 by
C2 by 4C2.
2C2, both women, and 4C2, right?
4C2.
Yeah. What is the probability that no woman?
Sir, 2C2 by 4C2.
2C2 by 4C2.
Yeah, 2C2 by 4C2. This is identical because we have equal number of men and women in this case, right? So
Yeah.
these are
Sir,
all
what
basic.
is the probability that committee does not form?
What is the probability that committee does not form? That is 0. Okay, so I think in quiz 2, most of the questions were not from this probability, right? It were basically from PNC and these counting principle. Yeah, there were a few questions, but there were a little questions from probability as well. Just,
Sir, sir, in this question, we can intuitively think that there are 2 men and 2 women. So probability of selecting 1 man out of 2 is 1 by 2.
In which question?
In this only, a committee of 2 people need to be selected from 2 men and 2 women.
no, it won't be 1
Which
by
part?
2 because there
Part
are 2
first,
people.
part second, or part?
Part first, sir.
Where did I go? Where did that go? Part first, part second, and part third. Which one you are talking about?
Part first, sir. Probability of selecting 1 man in the committee.
Okay,
So,
what you are saying?
So I'm saying that there are 2 men and 2 women. So it is I am selecting 2 men out of 4. So means
okay. 2 men. No, we are selecting only 1 man.
Yeah, 1 man. If it was 2 red ball and 2 black ball and selecting probability of selecting one means 1 red ball, that would be 1 by 2, sir.
It will be 2C1 over 4C2. Yeah. Would it be equal to 1 by 2? Is this 1 by 2?
No, sir.
So basically, that is why we need to see, like, these are all our favorable outcomes. That is why we have gone through PNC to see how this is coming, how this 2C1 and why this is coming, why my 4C2 is, 4C1. Yeah. Then if you're choosing 1 ball, then it would be 1 over 2 over 4. Yeah. If you're only choosing 1. Hello, am I audible?
Yes, sir. Yes, sir.
Okay, if you're choosing 1, yeah, then it would be that.
Then it would be 1 by 2.
It would be definitely what it is like. Then it's reduced to simple probability, right? You have 4 balls. Then there are 2 red balls. What is the probability that you choose a red ball? 2 over 4, right? So it's basically you can write it simply as 2 favorable, because I have 2 favorable balls that I read, and total I have 4 balls. But it's better to go through this because it also helps you solve when this is not applicable, when it's a little difficult to see this one. So it's suggested that you approach it in this way. Okay. Now I want to discuss one question that was in quiz 2. So it's Samsung mobile company has launched 2 phones. This one is 03 and S22. The probability that A03 has a good battery life is 60%, and this one is 80%. If a phone is randomly selected, then what is the probability that it has good battery life? what we will use here? Anyone?
Sir, total probability.
Yeah. Basically, I want to ask: will you be use Bayes rule or total probability?
Total.
Total.
Total probability.
Yeah, total probability.
Sir,
So
can
in
you
these,
repeat once base rule and total probability?
yeah, I will definitely. I will explain it through questions if that is fine. Okay.
Because sir, I have doubt in these two.
I will explain what I suggest to you do. Ma'am has also explained. If you are having a little doubt in this Bayes rule or total probability, what I suggest is go through this tree diagram. Okay. Now I will see. Now I have two phones. One is A03 and the second is S22. What is the probability of selecting one phone? Randomly it is, so it will be 1/2, right? Now, what is the probability it will have a good battery life? It's A03, 0.6, right? And it will be 0.8. Okay. What does this correspond to? This branch, I mean. What does this branch correspond to? This is basically probability of good battery life given that it's A03. Okay.
Yes.
So this is what it means in terms of tree diagram. Now, when to use total probability and when to use this Bayes rule. That is like a few people are confused there when to use total probability or when do we have to go for Bayes rule. Now, in this question, where was this question? I was asking about the end result, right? What is my at the end? I am concerned with this good battery life. At the end result, I don't know right now the probability of this end result. So whenever I have to deal with this end results probability, I will be going with total probability. Okay. That is there. And whenever this is given to me and I am asked something in between, either this, suppose it's given that the probability that it's given, it comes out to be something like 0.4. Say this is not exact. Say this is 0.4. What is the probability that it was from this one, Samsung A03? Then we will go with Bayes rule. So what I want to say is when we are asked about the end result, this one, go with this total probability. When we are asked with the something that is concerned with in the middle, this suppose A03 or S22, then we will go using Bayes rule. Okay. So this is how you
permutation will be there for basis rule.
Sorry?
If given is included in question, then we can go for basis. Given that like
yeah, it's much better to see it in this way. If you're like, sometimes they might confuse you with some terminology, right? Because language is a tricky thing. They can always confuse you with a little terminologies. So it's better to approach it in this way. If you know already what your end result is, what it's going to happen, what you are going to have at the end. Suppose in this question, I know at the end I am going to have a good battery life, right? I am concerned. No, I don't know. I have to see that what is my probability that it will have a good battery life. I don't know. So I will go with total probability. Now, suppose I was given that the phone has good battery life. So I already know this, right? So I know the end result. Now, suppose the question was, what is the probability that it was Samsung A03? So I know at the end, whatever we were concerned with, that is there, that's given. But I have to deal with something that is in the middle, like in the middle of this tree, right? So I will go with Bayes rule. Okay. Now to this question, did anyone solve this question?
Yes, sir. Answer is 0.7.
0.7. Yeah, that would be correct answer, right? It will be basically, it will be either it will be A03 and it will have a good battery life, right? From there or from there, right? So you multiply these two, you will get somewhere between this 0.7. This basically the answer to this question is in this range, 0.65 to 0.75. Okay.
So can you take that monsoon wala question, sir?
Yeah, I will take that. Yeah, I'll take monsoon. Okay, that graded assignment.
Yeah.
Sir, I have also a question.
Okay. I will take
Which
that.
2-1 question is there, sir?
Monsoon, that graded assignment week 8.
Okay, graded assignment week 8 monsoon question.
And
Okay,
sir, one activity question also.
11th question, sir. 11th question it is.
Okay. We'll get to all these questions, but let's go order wise. Okay, you just when I ask you, tell me which question it is. I will go towards that. I'll just see if we have covered first all this. So sample space, we know its basic definitions are there. Then
Well, monsoon wala question is the tree diagram questions.
yeah. I have already solved that questions. If
Yeah, that's right. That's right.
Some
Can
people
you,
forgot that flow.
can you cover
I
the
forgot the
concept
flow.
part of total probability?
Sorry, can you speak at once because there are a lot of.
Sir, can you cover the
voices.
concept part of total probability and the Bayes theorem?
Yeah, definitely. So this one was the question we just solved, that was total probability. I will show you how it is done.
So to find total probability, we have to
Multiply and add.
right? Okay.
So see, why do we need to multiply or add? This is total probability question. Someone was asking about the concept related to this total probability and Bayes rule. You understand when we have to use total probability and when we have to use Bayes rule?
Yeah.
Okay. Now, suppose now I have to use total probability.
Sir,
Yeah.
Sir, please, please start from start a phrase.
Yeah, this is
from
fresh.
total probability, please.
This is fresh.
Without
This is
taking questions, at first, can you elaborate the concept?
Concept is basically, what is the concept? You are given two events. Suppose there is two events are leading to one kind of outcomes, one same outcome, right? Now we want to know if this outcome has occurred, what is the probability that it occurred? It could have occurred either in this way or in this way. Suppose in this question, it's always, that's why I'm saying it's better to explain through a question, because it also gives you an idea what is happening. See, what in total probability, what we are concerned with is, I have an event. Suppose in this question, it was that a good battery life is there. Okay. And there were two phones. One was this A03 and this second was S22. I was asked, what is the probability my phone will have a good battery life? What I was given is one event, A03, which leads to good battery life. Suppose my A03 can have good battery life, right? Or my S22 can have good battery life. So these both lead to this one common outcome, right? Now I am asked, what is the probability of this common outcome? It can happen either. It can happen either in this way. Either this one will have good battery life, right? Or this one will have good battery life. Okay, somebody, there's a lot of disturbance from my mic. Can they mute? Okay, now it's fine. Am I audible?
Yes, sir. Yes, sir.
So, the final outcome that we are concerned with, it can occur in any one of these two ways, right? So, in this case, what we will be doing, we need to know the probability. How we will find it? I can have good battery life. I suppose I chose a battery and it had a good battery life. What are the possible cases that it could have happened? It could have happened in the way that I chose A03 and it had good battery life, right? Or what happened? I chose this S22 and it had good battery life. These are the both favorable cases which lead to good battery life, right? So here we will be concerned with total probability. I will explain Bayes rule with the same example. Okay. Now, what is my probability that I will get A03? Half, right? And what is the probability that it will have a good battery life? That is given 0.6. So this is what is this basically? This is that I have A03 and it has good battery life. A03 with good battery life. Good battery life. Or what can happen?
Having A03 and good battery life.
Yeah. Probability, this will be S22 with good battery life, right? So these are the only two cases in which I will get this good battery life, right? So when you solve this, this will come out to be 0.56, 0.3, 0.4. This will be 0.7. Okay.
Yes.
So this is your
So
total
probability
probability.
of having a good battery life is 0.7.
Yeah. So this is
Sir,
my
last time you
total.
calculated 0.65. What was that?
No, I did not calculate it. I left it there only. I didn't calculate. Where did I calculate this? No, I didn't calculate.
Okay, so
You
this
told
is
approximate value.
the law of using total probability.
Yeah, this is, sorry.
This is the total probability.
Yeah, this is basically total probability. If you want to translate this, what this is, if you want to like relate it with the definition that has been given, suppose this is my event A. This is my event A and this is my event B. Okay. How you can translate it is probability of A into probability. What is this? Probability. Suppose this is G. Probability of G given A or probability of B into probability of G given B. This is total probability. Okay. For these two events, it will be translated to that. This is how you translate this tree diagram into this given formula. So this was for this. Now,
sir, a related question to this.
Yeah.
I mean, this formula also gives you, it's related to the intersection of two events, right? There's a formula connecting to this dependent event. So is it possible to draw a Venn diagram of two independent events?
Sorry?
If I have two events which are independent.
Okay, right? So you are like confused in this, right?
Yeah, mutually exclusive and independent.
No, mutually exclusive and mutually independent events. The independent events doesn't mean that event is mutually this independent if it is mutually exclusive. What are mutually exclusive events? Probability of A intersection B equals to
null.
Phi. What is this for? Probability of A intersection
B.
I
got it. So I know the difference between the two, but what I wanted to see is it possible to draw a Venn diagram of independent events?
It depends on the question, right? Suppose this is this definitely for this, it will be definitely right. This, right?
Yeah, that I understood.
Suppose if this is non-zero, one of them is non-zero, then it will be like this. If it is either one of them is zero, then it will be zero, right? Then it will be something like this. So it entirely depends on the data that you're getting. This does not necessarily mean this. Okay.
But from the Venn diagram, it is not possible for us to tell whether the events are dependent or independent, right?
It depends on the data, right?
Okay. Got it.
So how we are taking that 1/2, sir?
Which 1/2? In this question?
Yeah,
it's there in the question.
Okay.
It's there in the question only. So this was for this. Now in Bayes rule, let me check if I have a good question related to Bayes rule.
Sir, there is a question in the quiz too. It is quite easy. Can you just explain me that?
Which one?
Just a second, sir. I'll just read it aloud.
Just tell me the question number. I'll go through it.
Sir, the envelope I
Parcels from sender
yes
to sender receiver R pass sequentially through two post offices. First post office has the probability 1/8 of losing an incoming parcel.
Okay. We have just a moment. Can you please repeat it? Because somehow this questions got closed. Can you repeat it?
Parcels from sender S.
Okay.
To receiver R.
Okay.
Pass sequentially.
Okay.
Through two post offices. First post office has probability 1/8 of losing an incoming parcel.
Okay.
And second post office has probability 1/5 of losing an incoming parcel.
Okay.
Which is independently of all the other parcels.
Okay.
Given that the parcel is lost, find the probability that it was lost by the second post office.
Okay. So basically, this is what we have been given, right? We have two post offices that Whenever it's not mentioned that probability of one event is different, we it's safe to assume that they are equally likely. Okay, until and unless mentioned otherwise.
Sir,
Okay?
it's the other way, sir. 1 second,
Sorry?
sir. So when the parcel is coming from post office 1 to post office 2, if the parcel is lost at post office 1, there is no way that the parcel will reach post office 2, right? So there is an important point here.
I need to just
both the post
just-
office it's sequentially, like it goes to one and then it goes to the other. Yes, sir. It's sequential. It is. Yeah.
It's sequentially going.
Yeah, yes, sir. It's sequentially going. Yeah, this question is from quiz 2, so it goes through sequentially.
So it first goes to post office 1, then it goes to post office. Okay, just a minute. I need to check this question first. Okay.
Yes, sir. It is that is
Sir, sir, I have given in chat box.
Okay.
Can I paste it in the chat box?
Yeah.
Sequentially means this. Okay, they're not.
Just a moment. Post office.
So 2 branches would be 1 by 8, and it's like other branch will be 7 by 8 into 1 by 5.
I don't have this. Okay. So what is basically I'm not able to accept this quiz 2 questions. What is given? One, it passes sequentially through this first post office, then it will go to the other post office, right?
Yes, sir.
It's basically like this. My parcel will come from this. Sorry. Then it will go to post office 2, right?
Correct.
So what is the question asking? Okay, some Prashant has posted it. Parcels from sender S to receiver pass sequentially through post office. First post office has a probability 1 by 8. Okay, probability is 1 by 8 of losing an incoming parcel in the second. So definitely it would have been lost by the second post office, obviously, right? First post office cannot lose it.
No, sir, there will be 2 cases for this.
What is either the first? Yeah, sorry.
One case would be that the first office loses it. The second case would be that the second post office loses it.
Yeah.
So if the first post office loses it, the probability is 1 by 8.
Second.
If the second loses it, it is 7 by 8 into 1 by 5.
You're not audible. What? So basically, we have these post office 1 and post office 2, right?
No. I'm saying post office 1 and other branch
is also post office 1.
This one. Okay.
Bottom branch is also post office 1.
Okay.
And for both, the next is post office 2 for both.
Okay.
No. Separately.
This
post
is what
office 2. Post office 2 and they collected that the parcel is lost.
So the condition is it is lost at post office 1. If it is not lost at post office 1, only then post office 2 can lose it.
So for the first one, for the first branch, it would be that the first post office loses it. So it is 1 by 8 for the first branch, and if first post office loses it, then the second one cannot lose it. So it would be 1. Just the probability would be 1. For the second branch, that the first post office doesn't lose it, it is 7 by 8, and the second post office loses it, it is 1 by 5.
Yeah. So basically, see what will happen. We'll have 2 cases, right? Either the first post office will lose it, and this is not tree diagram. I'm just explaining this. Okay, this is not the tree diagram. Don't. Either my first post office will lose it, then it won't go to the second post office. This is my one case, right? Or what can happen? My first post office will not lose it, and it will go to post office 2, and then it will lose it, right? So what is my probability of first post office losing this?
1 by 8.
The second case should be like both if first post office loses and then second post office should also lose it. That
is
can
the
also
first,
be a case.
No, that cannot be. If first post office loses it, second can never lose it, right? Because it's already lost. Since it is passing sequentially, as mentioned in the question, it is passing sequentially. If it is lost by the first post office, then what is the basically this probability of P2 given P1? It is 1, right? Because it's already lost by post office 1.
Not getting this 1 point only.
Just a minute. What can happen is parcel from memory to parcel. Common parcel. Independent of all other parcels. Okay, given the parcel lost by the second post office. So it will be like this: post office 1, it went there, post office 1 lost it, and or post office 1 did not lose it, right? So it will be post office 1 lost it. What is the probability? 1/8, and post office 1 did not lose it. Probability 7/8, right?
Yes.
Then we will have post office 2. What is the probability then? Post office 2 will lose this.
1/5.
It will be 1, sir, for the first branch.
Lost.
1.
P2. It will be for here. It will be 1, right?
Yeah.
It's already lost. This is basically this probability of P2 given P1. Now you know P1 has already lost it, so the probability is 1 because it's already lost, right? That has already happened. So what is the probability of this? That is given 1/5, right?
Yeah.
Now this has been asked. Which one has been asked? The second
bottom
one.
one. Bottom
Second one. So what is the probability this happened? So my probability, as I already also told you previously, that keep in mind this favorable over total. What is my favorable in this case? 7/8 into 1/5, right?
Yes, sir.
This branch is my favorable branch. What are my total cases in which this can happen? This can happen either this happens, right? 1/8 into 1 plus 7/8 into 1/5. Solve this, whatever you get is the solution for this question. Okay. Anyone has any doubts in this one? Anyone?
Yes, sir.
0.583, sir.
I will solve again if I
Sir,
have a
please
doubt.
repeat
I will
again
ask
the
you.
last part.
Okay, so this one, the last one where I solved this. Okay, see, what is my base rule? This is base. Whenever you're going for base rule, don't lose track of this basic formula. Probability is equal to favorable outcomes over total outcomes, right? What is my favorable outcome in this? This one, that post office 2 loses it, right? In this, what has happened is that post office 1 has lost it, right? So this is not my favorable. This is my favorable, that post office 2 loses. What is the probability of this? This is 7/8 into 1/5, right? What are my total outcomes? Means that the parcel is lost. It will either be lost by post office 1 or it will be lost by post office 2, right? So that will be 1/8 into 1. Basically, total probability you will use here. Or it will be 7/8 into 1/5. The second one loses it. Favorable divided by total.
Total
So
should, total should include 1/8 into 4/8, I believe. We are assuming that the parcel is lost in the first post office itself. That means that it is not lost in the second one. So how it can be 1? It should be 4/5, I believe.
It should be this probability of post office 2 given post office 1. What is my post office 1's probability? What is the if parcel is already lost in post office 1? What is the probability that it's lost in post of, like it is lost? It is lost. That's what I am saying. What is the probability that the post of this post is lost, given that it is lost in post office 1? 1, because it's already lost, right?
Okay.
That is how. So to explain this base rule, I will take another example. That's a little,
The dart question.
That
in
question,
which,
okay.
In which it has to less than 5 or
It was a
3.
practice assignment question, sir.
Yes,
Oh,
sir.
is it something like what is the probability that it will land in this area?
Correct.
Yes,
that is the
sir.
question.
So what you have to do is, if you are giving some particular area in which it has to land, what you will do is you will divide that area over total area of the dartboard. That is how you will get your probability. Okay.
Like the small circle area divided by total
By the
area.
total area. Yes.
So
That is
why we are not taking like this one? Can you draw the circle again?
yeah.
The smaller also.
Yeah.
So can we just do like total area minus the second path of this bigger circle?
So you are saying this total area minus this smaller circle. What will that give me?
No, sir. This bigger path.
Okay, this
Around
one.
this small circle. Yes, sir.
Okay, minus.
No, total minus this path area.
Total minus this path area. That will be this area.
What is
Yes,
this
sir.
question?
But the answer is not coming. The same.
I don't know what the question is. Just can you post it in the chat box? I'll look up at the question, or just tell me
Yes.
which question it is. I will go there.
Sir, I was just going through like solve with week 11 the same question and the circumference sorry, the radius of that particular big circle was 20 meter and the chance of winning was less than 5 meter if he just put the dart in less than 5 meter.
Okay,
So
so what
Yes,
is
sir.
my favorable? It is what is my it has to land within the radius of 5 meters, right?
Yes, sir.
That is, so what is my favorable outcome? Pi 5 square, right?
Sir, but I thought of doing like 20 pi square minus 15 pi
5.
square. 15
Okay.
square pi.
20 minus 15.
Yes, sir.
So that is giving you some area like this one, this outside area.
Yes,
What
sir.
are, so that is not what it has asked is what is the probability it will land here. So that is basically this circle's area, pi 5 square. This radius is 5. So this you just have to do it in this way. You have to take this circle's area divided by total area.
Okay, sir.
If you do pi, suppose this is 20. This is my, suppose this is somewhere 15. Okay, let me draw a circle, one more circle. Just a moment. My drawing is terrible, sorry. Just a moment. Suppose this is my 15 circle. If you're subtracting this entire, from the entire area, you're subtracting this much area, pi 15 square. What is this giving you? This outer circle, right? It's not giving you this one, the one we are concerned with. So that is wrong. You just have to take this one, the smaller circle that is asked. Okay, this was for this. I think, have you all gone through that geometric distribution?
Not till, sir.
Okay.
Sir,
yeah.
Can you repeat?
I will definitely come to Bayes' theorem. I was just, it came to my mind that there was this.
So,
yeah.
So this was the question I have doubt in the quiz. To please explain, sir. I have
Sorry?
posted in the chat box. I have posted in the chat
That
box.
left question, sir.
Okay,
Yeah,
there is a little ambiguity on this question. Yes, there is a little ambiguity. We have discussed it with the instructors, and they are currently discussing it. If like they are discussing it because there were some genuine concerns regarding these questions, and we have forwarded those. The day we got the doubts only, that day we forwarded it. So whatever they say, like you will get a notification if there is some change in the solution. Okay.
So the marks will also be updated.
Yeah, marks will be compensated. Yes. Whatever the outcome is, if it is not possible to change the marks of quiz 2, you might be compensated in the end term. Okay. And that would actually work in your benefit because
Sir, I will pray for that. Like we should be compensated.
If that, like if the answer they are discussing it within themselves, if they find the answer was not correct, then yeah, definitely you will be given this. But the thing is, the correct answer was also in the options, so it only those who have marked that correct answer will get those marks. The correct answer was also there. In
Yes,
now,
sir. 24 by 125.
12 upon 125.
Whatever that was, there is this the thing. Most like including myself, we have a doubt in the solution. So whatever the instructors now say, that will determine if that was right or wrong. Now, base. I will take one question on this base rule. Suppose bag one, I have one bag one contains, this is for base rule, okay, and I will explain how this is from base rule.
Sir,
Yeah.
actually, I have doubt in understanding the rule itself. So,
Understanding
start
in
from the base. So I'm
Excuse me,
not
sir.
getting what is this.
what are you
What
trying to
does it? What does it say?
base theorem?
Yes. Sir.
I will explain it with this question only. First, I will write down the question, then I will explain it. Okay.
Right. Okay.
Bag one contains 3 red and 4 black balls. This is one piece of information, and then it's given bag 2 contains 5 red and 6 black balls. One ball is drawn at random, okay? One ball, and it's found to be red. Ball drawn is red. Find the probability that it was from probability of bag 2. Okay, now I will explain you what Bayes theorem is, what total probability is. Here I will be able to explain it in a much better sense than that post office question. Why? See, what happens in this question is I have 2 bags, right? Suppose this is my bag 1 and bag 2. This is my bag 1 and bag 2. I have 2 bags. Now I am given that I choose a ball and I don't know which bag I chose it from, right? It's not mentioned, right? I have chosen one ball. I have drawn out one ball and I don't know which bag I chose. But what I know is that the ball is red. Okay. Now it has asked me what is the probability it came for bag 2. So in this question, what I know is I know at the end what I am getting, right? At the end, I am getting a red ball, right? So yes, it has asked what is the probability it came from bag 2, right? Now, suppose the question was framed like this. In this question, it is right now it is asked what is the probability. Somebody. Now, where was I? Okay. So if the question had asked one ball is drawn and find the probability it's red. Find probability it is red. Probability that it is red. Then what could have happened? Either I could have chosen bag 1 and I could have gotten this red ball, right? Or I could have chosen bag 2 and I could have got this red ball, right? But I did not know, I wasn't assured that at the end I am getting this red ball, right? I was asked what is the probability at the end you got this red ball. But when I am assured that, okay, I have got this red ball at the end, what is the probability it came from bag 2? Now I will go to Bayes rule. Because I know at the end what my end result is. I am given a surety about that okay, yeah, your end result is a red ball. Okay, now I have to come back to something in middle. That is Bayes rule. First of all, I will explain when to go for this Bayes rule and when to go for this total probability. Now, I was not given that at the end. Suppose I was not given that the ball is red and the ball I draw. Now I am given what is the probability that the ball drawn is red. I didn't know this, right? This is my end result, drawing a red ball. I wasn't given a surety it is red. What I was asked, what is the probability that it is red? Then I will go for total probability. Okay. But the moment I know this is red and I have been asked something related to these in between events, then I will go for Bayes rule. Okay. Now, how to go with Bayes rule? Total probability we just saw, right? Now in Bayes rule, there is I always suggest, for this course at least, we should explore this tree diagram that ma'am has also mentioned. Now, what my Bayes rule is, it seems very complicated. Probability of A into probability of something given A given B, right? It just confuses a little. We should know that formula always, but there is a simpler way to go. That is this Bayes rule. What I will do is my probability, as you know, is favorable cases by total cases, right?
Right, sir.
Okay. Now, if I got red ball, suppose I have been asked what is the probability that it was bag 2. What is my favored case here? Bag 2, right?
Right.
So bag
Yes,
2,
sir.
I'm just writing it for the sake of this. Bag 2 is just say for this ease. It doesn't represent anything right now. It's just I got ball from bag 2. What would be my total cases? Either it could have come from bag 1, right? Or
Plus
it could have
bag
come from bag 2, right?
Yes, sir.
Someone was asking about Bayes rule. Is this clear? Someone said I don't have much
Yes,
clarity
sir.
about Bayes rule. Is this clear?
Yes, sir. Yes, sir.
This is Bayes rule. There is nothing more to Bayes rule. This is Bayes rule. Now I will explain you with this example. Now what it is asked is find the ball drawn is red. I know the end result, right? End result is known to me that it's red. Find the probability that it came from bag 2. My probability of choosing a bag, it will be either bag 1 or it will be bag 2. My probability of choosing bag 1 is half and probability of choosing bag 2 is half. Since it is not given in the question otherwise that these are not equally likely, I have to take that probability of choosing a bag is equally likely, okay? Until and unless mentioned otherwise. Now, what can happen? I can choose bag 1 and I can get a red ball, or I can choose a bag 2 and I can get a red ball, right? These are my total ways of getting a red ball. Now, what is the probability? What is this? Bag 1 and red. 3/7, right? Because there are 3 red balls in bag 1 and there are total 7 balls, 4 plus 3, right? What is my probability of this from bag 2? It is red. 5/11, right? Now comes the solution part. What is the probability that, let's just take this somewhere else where we have much more space. Just a moment. There it is. So what is my probability that it came from bag 2? So what are my favorable cases? This branch basically, what is this 1/2 into 5/11, right? This is the probability that it came from bag 2. What are my total cases? Either it came from bag 1. What is the probability it came from bag 1? 1/2 into 3/7, right? Or it came from bag 2. What is the probability? 1/2 into 5/11. So solve this and this is the solution. This is Bayes rule. There is nothing more to Bayes rule than this. Okay, is this clear? Now suppose I was asked that what is the probability that it is a red ball? It is bag 2. What is the probability it was red ball? It could have been we could have chosen bag 1 and got a red ball, or it could have been bag 2 and it could have been a red ball, right? So this is total probability and this is Bayes rule. Okay, so the denominator of total probability is this Bayes rule is what you get in total probabilities, to put in other words.
If the conditions are specified that the ball came from bag 2, then we should go through Bayes rule. If they are just
if you are given
what is the probability of just getting red ball, then total probability is good.
Yeah, what I am saying is, let's not take red ball or black ball. What I am trying to say is this red ball, you can see this is my end event, right? If it is given that, okay, this end event has already happened. Suppose I got a red ball. The ball I draw, it is red. Then I will go for total probability. But if it is not given that my final ball is red, if what it is asked, what is the probability that this is final ball I draw is red? In this case, do I know the final ball is red? No, right? Because it isn't given. It's just asking what is the probability that it is red. Then I will go for total probability. But if it is given that it is red, then it has asked something related to these in between events, bag 1 or bag 2, then I will go for Bayes rule. Okay.
Thank you, sir.
So this was for this Bayes rule and total probability, I think.
Excuse me, sir.
Yeah.
So there's a sum which I think is also we have to apply Bayes theorem itself. It's in the chat. Could you just have a look at it?
Just a moment, I have to look at it.
Is it the line A and line B question?
Yeah. It looks like Bayes.
Yeah, it
Okay,
has got.
I don't have access to this. What you can do is you can just post it
Okay, you
on
don't have
Discourse.
okay,
No, I
yes.
don't have access. I don't have access.
Okay.
Just post it
fine.
on Discourse the question. I will look it up there. Okay, Discourse or
Sure, sir.
discussion for whichever one you have access to.
Okay.
This
Okay,
was
sir.
related to this conditional this basically Bayes rule and total probability. So I don't think there is much that has been covered in week 8. Week 8 is basically revolving around this only conditional Bayes and total probability.
So
Now,
can we take
just
one or two
just
more questions on
yeah,
this?
definitely. Before that, I want to just a moment. I will post something in the chat box. You guys just have a look at it, okay? Just a moment.
So could you try now or now are you in the answer?
Sorry, just a moment. I'll just post something in the chat box. You guys take a look at this. Okay, can you see this? I'm posted from a different account. There is a YouTube link.
Yes, sir.
So this is basically the YouTube link for this geometric distribution. So we will be discussing it tomorrow in the session as well. And I think you will get some update about this geometric distribution since it's not there in the additional content. So you all can go through this video. Okay, this is basically.
Is it the only video related to geometric distribution, or are there other videos as well related to this?
All that I could all that I could find was this video. But if you want to like explore more,
No. I was just asking because some distributions have more than one videos in the weeks, right? So I was just asking you that.
This is fine. Even if like what we will do is whatever we need for this end term from this geometric distribution, we will be discussing it in tomorrow's session as well, and you will get some notification, some updated notification about it also. Okay, we have already forwarded it, so it's just a matter of time you get an update about this. That's all. Okay, and let me take a few more questions.
Sir, we have got an email regarding this also.
Yes. You should go through this. What is this geometric distribution? Okay.
So this
Sorry?
one lecture is enough for geometric distribution, right?
Yeah, and whatever we will be discussing tomorrow in the session.
So what is the weightage of geometric distribution? How many?
I don't know. I don't know. Like basically, I also got to know from someone that this geometric distribution has been asked. I didn't know it, but most like for the exam, and as you have got mail as well, there is 60 to 70% weightage will be given towards the later weeks, right?
Yes, sir.
So that is there. You just prepare for that. At
Okay.
what at max, what can you expect? One question from this geometric distribution. If it is there, then at max one, right?
Yes, sir.
This isn't discussed in much detail. So at max, it can be one. Let's hope there is none, but it can be one.
Okay.
So suppose there is one more question. Suppose the reliability of a HIV test is as follows. Of the people having HIV, those who have HIV, okay, have HIV, 90% of the test detects the disease, okay? But which if 90% detects, that means 10% doesn't detect, okay? Of the people free of HIV, those don't have HIV, 99 of the tests detects negative because they don't have it, okay? It will detect negative. But if 99% detects negative, then 1% will detect positive, false positive, in other ways. That's reality. From a large population only in which only 0.1 have HIV, 0.1 have HIV. which means 99.9% don't have, right? 1% is selected as random. Okay, now given this test detects positive, it has detected it's positive. What is the probability that the person actually has HIV? So don't tell me, but post it in this chat box. What do you think? What we are going to use, Bayes rule or total probability? Post it in the chat box. I want to see it there. Okay. Yeah. So basically in this question, what I have given, I am given the end result. The person is detective positive, right? So I have been asked what is the probability he doesn't have. So a person can have actual HIV or doesn't, has or does not. Yeah, or what we can say is yes or no. Yes, he has or he does not. What is the probability a person has HIV? 0.1, right? And what is the probability that he does not have this?
99.9.
What is my data? 0.1% have HIV. Okay, this is 0.1% and this is 99%. So what is the probability that a person will have HIV? Am I audible?
0.001.
0.001, right? What is the probability that the person will not have HIV?
0.999.
0.99 basically, right? So a person can have HIV and he will be detected, or he doesn't have HIV and he will still be detected. Basically false positive, right? What is the probability is that he has HIV and he will be detective positive? What is that? 90%, 0.9, right? What is the probability he doesn't have HIV but he is still tested positive?
0.99.
No. This one. What is the probability he does not have HIV but is still detected positive?
1%. 0.99. You've given it.
I am saying this one.
Okay.
0.01.
0.01.
0.001, right? 1% it is. Yeah. Just a moment. Just a moment. So what is this 0.01, right? This is given in the question. This much information is given. Now, what the question is asking, that the person, it is detected that he is positive. Okay, so it is detected. Now, what is the probability he actually has this? So this branch is basically asked, right? He actually has it. So what will be my probability? 0.001 into 0.9 favorable. What are my total cases? 0.001 into 0.9. Either he has this HIV and he's detected, or he does not have HIV and he's still detected positive, right? Solve this and this will be your solution. Okay. So it will come up 0.083. It will be in this range, somewhere in this range. Okay. So this is Bayes rule. Now, suppose the question has asked, what is the probability that a person is detected positive? Then it would have been 0.001 into 0.9, that he has HIV and is detected positive, or the person does not have HIV and is still detected positive, right? So this would be then total probability, and that would be the solution for that. Okay. So that was for this total probability and Bayes rule. Yeah.
So first solution was for that. What was the question, sir?
First solution was that the person is detected positive. Detected. It is detected that this test comes out to be positive. Now, what is the probability he actually has disease? Second one was I select a person, and what is the probability that he will detect positive? That is it. It will be either he has the disease and he will detect positive, or he does not have the disease and he will still detect positive, right?
Yes, sir.
In these two ways it will happen. That is for the second one. And for the first one, we know it is that he has the disease and he tested positive, or what are the total ways he will test positive? Either he has the disease and he tests positive, or he does not have the disease but he still tests positive, right? So these are my total ways he will test positive. Favorable over total. Favorable over total gives my probability. So this is for this Bayes rule. So I think we've extended well beyond the time limit. And we've already, if someone still has any more doubts, they can watch this session. It will be available on YouTube. And also that we have a revision session for the week, these weeks already that we covered previously before quiz 2. They can watch that as well. Okay. So tomorrow we'll be taking this revision session from week 9 to 12. And this geometry distribution will be covering that as well. Okay.
Sir, the
Yeah.
problem solving session, if it is possible, it may be recorded and provided to us. Like
the problem solving session is basically, it's like we have covered all the weeks already. So there are no more problem solving sessions now. And we did not record those problem solving sessions.
Sir, in math, they record and provide the recordings.
Yeah. Basically, they are now recording, but we're at this moment we are not recording those problem solving sessions. We're just recording these.
Earlier
and those,
also I requested for this.
yeah. But what we are having those solve with the sessions basically to cover for that. So now it won't be possible because it has already all the content has already been covered.
Sir, I have doubt in question activity 8.7.
Sorry?
Sir, I have doubt in activity 8.7.
8.7 activity. Just let me get there. Okay, which question?
Sir, question number 4 and question number 7.
Okay. So this question, I would see what happens is when we are solving a question of one topic, so we tend to solve it using only this concept, right?
Yes.
So I would suggest you to not look at it using Bayes rule. You can, that would be much like, that will be a little difficult, but don't look at using Bayes rule. Look at using simply, I will tell you how you should approach this. You can approach this. A task is given to 3 students, right? How will the task be completed? Either suppose Riddhi will complete it and Shivansh and Pratik will not complete it, right?
Yes.
The task will still be completed. Or what can happen is the second person completes it and the first two don't, the first and the last don't complete it. Or what can happen is Pratik will complete it and Riddhi and Shivansh won't complete it, right?
Yes.
Or what can happen is Riddhi and Shivansh will complete it and Pratik won't.
Yes.
Or what can happen is Riddhi and Pratik will complete it, Shivansh won't.
Yes.
And one second last case will be Shivansh and Pratik will complete it and Riddhi won't complete it. And there will be one case in which all of these will complete, right? You know the probability of them completing. So you also know the probability of them not completing, right?
Yes.
You just substitute values in this equation, you should get your answer. And it's a little simpler to think of such questions in this way, right?
That will be the probability of A union B union C. You can compute like that only.
Basically, what you can do is either one of those 3% is completing, or either one is completing, either group of 2 people is completing, or all 3 are completing. That will be there, right? So that is how you should, like, you can approach this.
So can we not handle it like, either A or B or C can complete it?
Yeah, probability of A union B union.
That's what I'm saying.
Yeah.
Okay. When we are saying probability of A union B unions, A union B for that matter, what does that mean? Either A or B, or both A or B, right?
That's right, sir.
So you can think of it in that way, okay? So I suggest you to just, like, if whenever you are going through activity questions, to not just look at them this topic wise. Now that we have covered the entire content of the 12 weeks, there, like suppose in this week 7, 8, there might be some questions that you can easily figure out. Okay, this is from binomial or this is from Bernoulli. Then try to approach it in that way also, right? It just gives you a diverse ways to look at a question. Okay, so that will be all from my side today for this session. For tomorrow, we will be covering this week 9 to 12. Okay.
Thank you, sir. Good night.
Yeah.
Goodbye. Thank you, sir. Have a good night.
Thank you, sir.
Yeah. Good night, everyone.
Good night, sir, and thank you, sir.